Jai Hind, dear students. Once again, welcome to the mathematics class. In our previous two classes, we all have discussed the basic terms which are associated with Introduction to Trigonometry chapter, the six trigonometric ratios and how to find out the values of the trigonometric ratios for different triangles, measurements of whose sides are known to us. Now, in today's class, we all are going to study the next topic, that is trigonometric ratios of some specific angles. Till now, what we did was finding out the values of trigonometric ratios when the length of the sides of a right angle triangle was known to us. Now, what we will study today, that if we know the angle which are formed in a right angle triangle other than right angle, then what will be the value of those six trigonometric ratios? It can be done for all the angles, but for class 10 syllabus, we have only certain specific angles and they are 0, 30 degree, 45 degree, 60 degree and 90 degree. So we will start with the angle 45 degree and try to find it out that what will be the values of various trigonometric ratios if the angle is of 45 degree. So we will start with 45 degree. For this we need to take a triangle whose one angle has to be of 45 degree. So for a right angle triangle, if I consider an isosceles right angle triangle as it is visible now on screen, then in that case, obviously this side AB and BC will be equal, and we know that according to the properties of the triangle, that if two sides of a triangle are equal, then the angles which are opposite to these two sides will also have the same measurement. Like for this triangle, if we have taken AB and BC are equal, then this will gives us that the measurement of angle A and angle C will be same. Also, in this triangle, this angle is already of 90 degree. So the sum of remaining two angles will be of 90 degree. And since both of them are equal, so each one will be of half of 90 degree, that is 45 degree. Which means for an isosceles right angle triangle, the angle other than 90 degree will have the measurement of 45 degree each. This angle will also of 45 degree. Now, for our convenience, we will consider that the length of AB and BC are of a unit. We took the value of the length of the line segment AB as a unit, then definitely length of BC will also be of a unit. Now we use Pythagoras theorem to find out the length of the third side. As we have already studied in our previous classes, that to know the value of any trigonometric ratio for any of the acute angle of a right angle triangle, we should know the measurement of all the angles or all the sides of a triangle. So for the same, what we are going to do is to calculate the length of AC by using Pythagoras theorem. So AC will be square root of AB square plus BC square. In terms of values, it will be A square plus A square. So further we can write AC as root under 2A square a square can come out from the root and it becomes root 2a. So what we have obtained, the value of AC as root 2a. So now we can see that we have the length of all three sides of this triangle ABC. Once we get the measurement of all three sides of a right angle triangle, we can determine any of the trigonometric ratios or the value of any trigonometric ratio. So let us begin with sine. Suppose if I have to calculate sine of angle A, sine A. For sine A, if I am considering this, then the side adjacent to it will be considered as base. This will be perpendicular because it is opposite to the angle, and hypotenuse, as we all know, remain same, that is opposite to right angle. So now if I have to write down the value of sine A, we know it is perpendicular by hypotenuse. For this triangle, it will be perpendicular, that is BC, upon hypotenuse, that is AC. So now if I have to calculate sine, angle A is of measurement 45 degree. So sine 45 degree is equals to BC has a length of A unit upon AC is of the length root 2a. Now A and A will cancel out and we will get the value of sine 45 degree as 1 by root 2. So hence you can see that the value of sine 45 degree for any triangle who have any measurement of their corresponding side. If one angle is of 45 degree for a right angle triangle, then the value of sine 45 degree will always be of 1 by root 2. Same way, if you try to calculate the value of cos 45 degree, we know that cos theta is equals to base by hypotenuse. So it will be AB upon AC. AB is again of A unit. AC is of root 2 A unit. On further simplification, it gives the same value as of sines, that is 1 by root 2. In the same manner, if we calculate tan, so tan 45 degree will be equals to perpendicular by base, which means BC upon AB. So it is A by A, and that gives us the value of tan 45 degree is equals to 1. So I hope you all must have understood how we have geometrically calculated the value of 45 degree for all the trigonometric ratios. If you wish, you can calculate for the remaining three trigonometric ratios also. Like we know that cosec is just the reciprocal of sine. So if I have to write the value of cosec 45 degree, it will be hypotenuse upon base perpendicular, so it will be root 2a by a, or which gives you root 2. Same way you can calculate for the others also. I am not writing the other trigonometric ratios over here. You all can do it as your work. So with this is how you can find out the value of 45 degree angle or value of trigonometric ratios for 45 degree angle. Now moving ahead, we will study or we will discuss how to evaluate the values of trigonometric ratios for 30 degree and 60 degree. So for 60 degree and 30 degree, once again, we require a triangle in which at least one angle is of 30 degree and one angle is of 60 degree. So for 60 degree, you all can imagine that if I consider an equilateral triangle We know that measurement of all the angles of an equilateral triangle is 60 degree. So let us consider an equilateral triangle. Let's label it. So I have taken an equilateral triangle ABC. So we know that the measurement of each of its interior angle is of 60 degree. So we got 60 degree. But this will not solve our problem. The reason behind this is, one, we need a right angle triangle to apply trigonometric ratios. Second, we still require an angle of 30 degree, because I have written that I am going to do both over here together. So now what we are going to do is to draw a perpendicular from A to BC. And here it is. We know that in case of an equilateral triangle, the perpendicular, the median, the angle bisector all coincide. So if I'll write that point as D, then if I have drawn AD as perpendicular, the AD acts as the median also, AD acts as an angle bisector also, which means AD is a perpendicular to BC. AD bisects BC, means AD divides BC into two equal parts, which means BD is half of BC. And also AD will divide the angle A into two equal parts. So the complete angle A was of 60 degree. Now the portion which we get as angle BAD or CAD will have the measurement of 30 degree each. So this angle B is of 60 degree now, and angle BAD is 30 degree. So with this, we have got all those things which we actually require. We required a right angle triangle. So we got ABD as a right angle triangle. We were required 60 degree and 30 degree angle. We got both the angles in triangle ABD. So for further calculation, we will consider only triangle ABD. Let's move ahead to find out that what will be the values of 60 degree and the trigonometric ratios when the angle is 60 degree and 30 degree. So for the same, if I'll consider the side of that equilateral triangle which we have constructed in the beginning as a unit, then BD will be half of A, that will be A by 2. And once again, for calculating the length of AD, because we know to find out the values of trigonometric ratios, we require the measurement of all sides of the triangle. So we calculate AD using Pythagoras theorem. So using Pythagoras theorem, the length of AD will be square root of AB square minus BD square. Further simplifying it, AB is of A unit, so A square, minus BD is A by 2, so it will be A by 2 whole square. If we move on with the further calculation, we can write it as A square by 1, and when you open this bracket, it becomes A square by 4. Now we take LCM. So we will get 4A square minus A square upon 4, which gives us the value as 4A square minus A square as 3A square by 4. Now 3 cannot come out from the root, so it will remain inside the root. A square will come out from the root and 4 will come out from the root. 4 becomes 2, A square becomes A. So we got the value of AD as root 3 by 2A. So we can write it as root 3 upon 2A. So we are all done. As we know, once we get the value of the length of the all three sides of a right angle triangle, we can find out the value of any trigonometric ratio for any of the acute angles which are present in a right angle triangle. So let us begin with 30° first, or let's take 60° first. So if I calculate sine of B for angle B, this AD will be perpendicular, this BD will be base, hypotenuse will be AB. So sine B is perpendicular by hypotenuse, so it will be AD upon AB. So now sine angle B is of 60°, so it is 60°. Value of AD is root 3 by 2a upon AB is of a unit. A and A will cancel, and it gives us the value of this as root 3 by 2. So we got the value of sine 60° as root 3 by 2. Same way, if I wish to calculate cos 60°, cos theta is a base by hypotenuse. So base will be a by 2 upon hypotenuse, that is a. Again a and a will cancel. We will get the value of cos 60 as 1 by 2. Same way, if I go to calculate the value of tan, so tan 60° is perpendicular by base, so it will be AD upon BD. AD is root 3 by 2a upon it is a by 2. So a and a, 2 and 2 will cancel. We will get tan 60° is equals to root 3. So I have shown you that how can we calculate the value of these trigonometric ratios for 60°. Same way we can go on for the angle 30° also. Now if we consider this, perpendicular will be BD, hypotenuse will remain as AB, base will be AD. Now if I have to calculate say sine of 30°, it is perpendicular by hypotenuse, that is BD by AB. So BD is a by 2, AB is a. On solving, it gives sine 30° is equals to 1 by 2. Same way we can calculate cos 30° also, that will comes out to be root 3 by 2. Same way tan 30° will come as 1 by root 3. If we want to calculate any other, say if I want to calculate cot 30, it will come as root 3. So in this way you can calculate the value of all the trigonometric ratios which are required to be calculated for a particular angle. So we did it for 45 degrees, 60° and 30°. The geometrical interpretation of 0° and 90° is out of the syllabus this time. So we will not be discussing those, though we will see what will be the value of these trigonometric ratios if the angle becomes 0° or 90°. So now if you all can see your NCERT book, there is a table 8.1 in which the values of all the trigonometric ratios for 0°, 30°, 45°, 60° and 90° are given. Here in the next part, we will discuss how easily we can prepare that table. Though you all have to learn these values also, which when you keep on solving question by using these values, you will automatically learn this. Otherwise, if you want to write down the table, how will you write? So let's see in the next part of it. So here we are going to start with the table formation. So the angles which we have considered are 0°, 30°, 45°, 60° and 90°. For all these 6 trigonometric ratios, sine, cos, tan, cosec, sec, cot. Once again I am revising. Sine, cos, tan are basics. Cosec, sec and cot are the reciprocal or the inverse of sine, cos and tan. Now if I want to write down the value of sine A for 0, 30, 45 or 60 or 90 degree, what we need to remember is just 4 numbers: 0, 1, 2, 3, 4. Among all of them, the largest number is 4. We divide 0 by 4 in first, 1 by 4 in second, 2 by 4 in third, 3 by 4 in fourth, and 4 by 4 in last one. And then we take square root of all this. What I mean to say is this. For the first one, we took the number 0, divided it by 4, and then we took the square root of that number. So we know that 0 by 4 is 0 and square root of 0 is 0, which means the value of sine 0 degree, means the value of sine for the angle 0 degree is always 0. Now for 30 degree, we have already calculated that for 30 degree it is 1 by 2. So how it can be? As I said, after 0, 1 will come. So 1 divided by 4, taken the square root of 1 is 1, square root of 4 is 2. So we have written 1 by 2. For the next one, we write 2 by 4, take square root, 2 by 4 is 1 by 2. Square root of 2 is not terminating decimal, so that's why we written it in the form of root 2 only. So it is 1 by root 2. Same way, when we write 3 by 4 and take square root, it becomes root 3 by 2. And when we take 4 by 4, it becomes 1. So you can see what we did. We have taken 0, 1, 2, 3, 4 for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Divided each by 4, taken square root of them, and we have done. Once you have completed the first, for cos, you don't have to do any this calculation. We just have to write down the same row in a reverse order. That means 0 will come to last, 1 will come at first. How? It is like this. 1, then root 3 by 2 second, 1 by root 2, then 1 by 2 and then 0. So we have just written the first row in reverse order and we have got all the values of cos theta. Same way for the tan, we know that tan is the ratio of sine and cos. In the very first class, I have told that tan is the ratio of sine and cos, or you can say it is sine divided by cos. So we simply divide row wise first by second. So 0 by 1 will be 0. 1 by 2 by root 3 by 2 becomes 1 by root 3. 1 by root 2 upon 1 by root 2 becomes 1, and so on it will go. So here it is how it will look. So first row divided by second row will gives you the value of third row. That's how we can do. For cosec, we need to do the reciprocal of sine. So if it is 0, it becomes 1 by 0. See, in the tan at the last, we have written not defined. Why is it so? Because if you see, sine A for 90 degree is 1, cos A for 90 degree is 0. So if you write 1 by 0, we know that division by 0 is not allowed in mathematics. So that's why the value is not defined. Same way for cosec, we just need to do the reciprocal of sine. So 1 by 0 is not defined. Reciprocal of 1 by 2 is 2 by 1 or simply 2. Reciprocal of 1 by root 2 is simply root 2. Reciprocal of root 3 by 2 is 2 by root 3. And so we get this table. For sec, we just have to again reverse the order of cosec and we will get the table. That means 1 come at the first, not defined will go at last. And how it is? This is how it is. For cot, you just have to write the values of tan A in reverse order, means again not defined will come at first and 0 will go at last. And this is how you can complete your table. So with this, you can prepare your own table wherever it is required. But yes, I'll say you all should learn all these values because it will be helping you not only in trigonometry. There is the next chapter which is application of trigonometry. In fact, it is going to help you out in the next upcoming chapters, whether it is circle, whether it is mensuration. And in class 11th and 12th, it is used everywhere in physics and chemistry as well. And all these values has to be learned. So with this, we come to the end of the today's class. In the next class, we will be discussing the questions of the second exercise of this chapter. Till then, happy learning. Jai Hind.